So for the last part of section 4.5, we're going to be switching things up a little bit. Rather than graphing given an equation, you're going to be finding the equation given a graph. So we're going to do two examples. The first one here, A, is this graph, and then the second one is B. I had to kind of break this up like this because the Notes app wasn't doing what I wanted it to do, but this will work. So the first thing I want to point out is they both look like they're sine graphs or cosine graphs, and it's really okay to use either sine and cosine. So you can choose what you want your equation to be. You can say, I want this to be a sine graph, I want this to be a cosine graph, and then you can solve the entire problem using either one of those, because sine and cosine are really just horizontal shifts of each other. Now I will say that I usually use cosine. Oops. So I usually use cosine because it's usually easier to find a maximum. And with cosine, we're always looking at maximums because the cosine starts with its maximum on the y-axis. So it's easier to find a maximum than it is with sine. You have to find the midpoint. But really, like I said, it doesn't matter too much, but I usually do use cosine. So in this problem, we'll go ahead and use cosine, and I'll also do an example using sine. Okay. So we have our graph here, part A, sorry. And there's a couple things we need. We need the amplitude, we need the period, we need the phase shift, and we need the midline, or the vertical shift. So to begin with, you can already start to suspect some things. You can suspect that it looks like it gets up to 2.5 and goes down to 1.5, so the midline looks like it's 2. But let's go ahead and do this in detail. So the first thing I'm going to point out is that the maximum occurs at 2.5 and the minimum occurs at 1.5. So this tells me that the midline, or the average value, is going to be, the reason I call it average value is because it's actually the average of these 2 points. You might just be able to recognize that that is 2 already, or you can use this formula to do it. 2.5 plus 1.5 is 4. 4 divided by 2 is 2. So the midline is going to be the line y equals 2, which is good. Now to find the amplitude, we're going to kind of go directly from here. To find the amplitude, we really just need the distance of the maximum from the midline. So this tells me the amplitude right off the bat, which is good. So now we have two pieces of information. Next thing I'm going to do is take a look at the horizontal shift. So remember I said cosine is always dealing with maximums. So all you have to do is take a look at this maximum point. And it should be on the y-axis, but it's not. So it moved to the right 0.5. So just kind of drawing a rough sketch of that here. This point should be right there. So that means that it actually moved, so regularly cosine would be there, it moved to the right by 0.5 because this is the x value of 0.5. So that tells me that the phase shift is also 0.5 like the amplitude. Now finally the period probably takes the most amount of work. So the period looks like, so where it repeats itself, I'm looking for 2 points that match. Looks like I have a minimum and then another minimum. So going back to my rough sketch here, this minimum and then this one. But really you're just looking for any point where they repeat. It looks like that's the only point that does repeat here. So that's what we'll have to use, negative 1.5 to 0.5. So that tells me that the period is this distance, which is 4. Okay. So now I have all of my information that I need, which is great. The next step is to actually write this as an equation. Now remember, the equation is y equals a, we're using cosine of b and then x minus c plus d. I have most of this information already. This is d, this is going to be a, and then this will be c. But remember, the period is not actually b. I have to solve for b using this formula. And so if I reduce that fraction, I end up with pi over 2. So now I can put everything together and I get y equals 0.5, b is pi over 2, x minus 0.5, and then plus 2. And so this would be my final equation for that graph. And then you could always go into Desmos and double check it if you'd like. You can always open up the Desmos app and let's see, it was a cosine graph. Boop, boop, boop. Let's go ahead and do cosine. This is going to be pi over 2. We shifted by 0.5. And then I have, whoops, way too many parentheses in there. Well, I sort of messed up there. I was trying to go too quickly. I think you all get the idea though, so you can go ahead and graph that. Okay, let's go on to the next problem. So this one, let's go ahead and I said I would try to do a sine in this one, so let's go ahead and do a sine example. So let's go ahead and really all that changes if you use sine or cosine is that phase shift. So let's go ahead and start B. So I'm going to find the midline again. So I'm going to take the average value. It looks like the max is 2.5 and then negative 0.5. So we'll go 2.5 plus negative 0.5 divided by 2 gives me 1. So that tells me that the midline is y equals 1. The amplitude is the distance from 1 to its maximum or to its minimum, and it's 1.5 in this case. The phase shift. Now this is where it matters if you're using sine or cosine. So let's just go ahead and say that I'm going to use sine, which means now what I'm doing is looking for a midpoint rather than the maximum. So if we take a look at our graph, oops, I've done that a couple times now. So if we take a look at our graph, it sort of starts up here, comes back down, and continues that way. The midline is at 1. And so this is the point, if you're thinking about the sine graph, this is the point that should be on the y-axis. And so I would say that the phase shift here is it moved to the right by 1, 2, 3, 4, 5 pi. So this is the point right here, 5 pi. And it should be at 0 if we're using sine. So that means my phase shift is going to be 5 pi to the right. And then the period in this case, it goes from negative pi. I'm looking at maxes now. That's when it repeats, negative pi to 7 pi, so the period is 8 pi. So I was looking at these 2 points because those are the ones I can see repeat. So then this distance is 8 pi. So really when I'm trying to find the period, I'm just looking for 2 points that I know repeat themselves. So usually I'm looking for maxes and mins because those are the easiest to spot. Now before we do this, because I know I'm going to have to do this eventually, let's go ahead and just solve for b. So it's 2 pi over the period is 8 pi, which just comes out to 1/4. So then my final equation is here's D, here's A, here's C, and here's B. So my final equation is y equals 1.5. I'm using sine this time. B was 1/4, and then x minus 5 pi, and then plus 1. And then just to double check, I will actually go ahead and double check this one this time, and I won't try to rush it. So I have y equals 1.5 sine of 1/4. Hit the arrow to get out of that denominator. It's going to be x minus 5 pi, close that parentheses, and then plus 1. Now you'll notice this doesn't really look good right now. And that's because we need to switch to radians mode. And it still doesn't look good because notice my axes are still off. So what I'm going to do is go ahead and zoom in so that I'm in kind of the right spot here. Let's go ahead and switch our step. Instead, we'll go by pi. And so now you can see that the graph actually does match up, right? So negative pi hits my maximum of, should be 2.5. Yeah. And then it also, at 3 pi, I hit my minimum. And you can see there the line y equals 1 is sort of in the middle there. You could always graph y equals 1 as well. And then we have our sort of 5 key points there. Cool. So that is how you would find the equation given a graph, and that actually concludes all of section 4.1.